Good morning, everyone. It's time for another video, and I'm doing a series. Hopefully, I'm trying to get it done in 5 minutes or less. Very hard to do, unfortunately. But anyway, math does not lie. It's factual. This is part 2 in a series I'm doing on Does God Exist? And how can I prove it using math? Well, Eugene Wigner, quote, "The enormous usefulness of mathematics in the natural sciences is something bordering on the mysterious, and that there's no rational explanation for it." Well, that's true for an atheist, but it's not true for a theist. But since we supposedly live in random universe land, of course, it does not make sense why you can do math at all. How can we calculate, how to fly a rocket from here to the moon, or how can we calculate where the sun is going to be 100 years from now, 1,000 years from now? We can know where it's going to be. Anyway, so the universe is supposedly random, at least it got here randomly, and then all life was random, and everything's random, and yet it's really weird, at least to the atheist, that mathematics is so useful. But I was this video is going to be something about I was debating an atheist on. Now, this is what I wrote. This was my comment. This is the comment that I wrote that got the ball rolling. And of course, it talks a lot about cosmology, which I'm not going to talk about because, well, you'll see here in a minute that the only response I got on the cosmology was something short and sweet. But what the atheist did is he barreled in on number 5, and he trashed Sir Fred Hoyle. And one of my favorite things to say is, any probability greater than or equal to 1 chance in 10 to the 50th power is a miracle. And everybody hates that one. So anything, again, I just want you to remember it. Any probability greater than or equal to 1 chance in 10 to the 50th power is a miracle. And that's all you have to understand. It's a probability. And you don't really have to understand it. Just remember, if it's higher than 10 to the 50th power, okay? So my contention was you believe in fairy tales if you believe that any of this, and I was talking about the whole comment, happened by chance. It's an actual, factual, scientific, mathematical impossibility. But, so my atheist friend, here was his first response, and then I give you my response to it. Again, I'm not going to go over this part. I'm just going to tell you. You can pause the video, and I give you some other videos you can look at that explained most of the comments that I made. Of course, like I said, what he does is he hones in on Fred Hoyle, and that's where we're going to start, because I get an atheist that finally comes up with some numbers, and that's what I'm interested in. If I can use their numbers to prove my point, then they have no beef. If I can use atheists, like, let me show you this. In all of these little videos, it's filled with atheists. None of this science is my opinion. It's atheists' opinion, and I do that on purpose. Anyway, so in this particular comment, of course, he starts out with Fred Hoyle, and we were talking about enzymes. Well, what's an enzyme? An enzyme is a molecular machine that does a specific thing in the cell, and we'll talk about that a little bit later. But what really caught my eye was he says, first of all, we know of bacteria that can live with fewer than 400 protein coding genes. Okay, that's the important part. 400 protein coding genes. Well, what's a gene? It's a section of DNA that has the information needed to translate first into an RNA molecule, then the RNA molecule goes out into the cytoplasm from the nucleus, hooks up with a molecular factory called a ribosome, and then it builds a protein, okay? So again, there are fewer than 400. That's his claim. And then he makes the claim that there are no enzymes necessary for the first cell. I call that bunk, but I'm going to let him have his way here. Okay. So I said, okay, fewer than 400 protein coding genes. Here's my response. I said, okay, let's say 300. Let's say 300 coding genes, just for his benefit. So I said, now just the facts, and that's all I want are facts. The fact is a single gene can code for multiple proteins. It's a phenomenon known as alternative splicing. So question, what is the average number of bases in a gene? Well, the answer, the average gene consists of 3,000 bases. The significance is the bases are the information that is needed to be translated into an RNA molecule, which is then taken from the nucleus out into the cytoplasm. It hooks up with a ribosome, and each base then becomes a corresponding amino acid used in a protein. That's what it does. Now, quote, the average number of amino acids in a protein, that's important too, varies depending on the organism. But a reasonable estimate for a typical protein is around 300 amino acids in prokaryotes and 400 in eukaryotes. Well, we're going to stick with the prokaryotes, the bacteria. That's what we're talking about. Luca, our first ancestor, that's what we're interested in. And again, to be conservative. So we're going to use 300 coding genes. Okay. Well, 300 coding genes that have an average of 3,000 bases on average. Well, that's, when you multiply that out, that's 900,000 bases. Say what? That's right. 900,000 bases in just the right order so that it can encode proteins for the next cell. The cells have to have a specific order of amino acids in the protein. It's not haphazard. It's not happenstance. It's very specific. So the atheist, he has no explanation for how that much information got encoded magically into the first cell from the get-go. He doesn't know. Even if you want to say, oh, it came from DNA or an RNA, I don't care. You cannot explain how 900,000 bases got encoded for the first cell to replicate itself. Now, we're going to take the 900,000 bases and we're going to divide it by 300. Why? Well, because, again, that was the average length of a protein. So, and since each base represents an amino acid, again, you take 900,000 divided by 300, well, you have 3,000 protein molecules that are available. Now, that's 3,000 possible protein types. That's not just 3,000 protein molecules only. We're talking about 3,000 possible protein types. Why? Well, the gene, it can be used to make as many copies of any protein that a cell needs. And certain structures need more copies of a certain protein than other structures do. Anyway, in fact, there's anywhere from 10 to 500,000 copies, depending on the place in the cell that it's a part of. Now, here's another problem. Proteins, again, are put together in a specific amino acid order. Now, in this particular example, we're talking about what they call the Leventhal paradox. And it has to do with a protein of only 100 amino acids long. And not only do you have to get the protein in the right order, which is an exponential problem, you also have to fold it. It has to be folded in a certain way in order to produce the enzyme or structure of the cell that is needed. And here's the problem. Protein of only 100 amino acids long. Well, the possible ways it could be folded, just folded, mind you, is 10 to the 95th power. And what did I say about miracles? 10 to the 95th power, and according to this, even if the little protein was sloshing around trying to find its shape, even in picoseconds, which is very, very fast, even a small protein that initiated folding by random search at the time of the Big Bang would still be thrashing about today. That's the Leventhal paradox number 1. So not even one small protein, only 100 amino acids long, would fold correctly out of the 3,000, and again, that's 3,000 types needed in 10 to the 18 seconds, or 13.6 billion years. And again, this does not include the fact that the protein and amino acid order must also be correct at the same time, which adds to an exponential complexity an atheist must explain but cannot. The origin of life by chance story is a pure fiction, and the math doesn't lie. But it's going to get worse. So here's the response from the atheist. The atheist, his first quote, he quotes back to me, okay, this is what I said. Let's use your example, fewer than 400 coding genes, so let's say 300, okay. So his response, well, that's not my value for the origin of life, nor it is the value used by the origin of life scientists. Really? That is a modern cell. Please learn to read. Well, okay, let's see if he's right. So my response, quote, is this, that if that's not the number, tell me what the number is, okay? And so here's my number that I've that I give out all the time. Origin of life researchers say that there are a minimum of 206 different types of proteins. That doesn't mean only 206 protein molecules. No, 206 different types, okay? Some molecules are even up to 200,000 amino acids long, and anywhere from 10 to 500,000 copies are needed, depending on where it's at in the cell. So those numbers, like I said, are off the chart complex. And it wouldn't be met by any primordial cell. It's all a big fairy tale by the atheist. And then I give you the Leventhal paradox number 2, and I don't want to talk about that because it doesn't matter for right now. He brought up James Tour. He says, oh, well, since you bring up the paradox number 2, 1 chance in 10 to the 79 billionth power. He says, well, since, James Tour brought it up, it doesn't mean anything, but at the end of this comment, you can see I give you the paper where it was from, and Leventhal paradox number 1, which we've talked about. So the atheist exact response is I'm going to share it with you in 2 separate quotes. First, he quotes me, well, what is the number then? Let's use that. And he says, I already said that too. Jesus blank Christ. Can you not read? So what he's talking about, I believe, because I read it, the atheist claimed that no enzymes were needed for the first cell. Well, enzymes are made out of proteins, by the way, but an enzyme is just a molecular machine, as I have explained it to you. And I have an example here of RNase H, which is just an enzyme, and what does it do? Well, after the RNA molecule is taken out to the cytoplasm and used by the ribosome to build the protein molecule, the RNase H, breaks up the RNA molecule. Otherwise, the cytoplasm would fill up with nothing but RNA molecules. So anyway, it breaks it down. Question really is, what came first, the chicken or the egg, the enzyme or the RNA molecule? Of course, they say RNA. Fine, I don't care. But here's the point. The cell, without the enzyme, the molecular machines, is not made of enzymes, but is composed of a minimum number of other protein types. In other words, enzymes are only one facet of the cell. It's not the whole cell. The whole cell is not made of enzymes. Like Sir Fred Hoyle said in my quote, there are about 2,000 of them in a modern day cell, and this guy railed against that. Fine. Okay, you can rail against it. Fine. That's fine. But quote number 2, well, even the simplest cell requires OOL, researchers say, 206 different minimum types of protein. That's what I said. And here's his answer. No, they don't. Not for the origin of life. Stop blanking lying. So here's my response, and this is secular science. This has nothing to do with religion. The last universal common ancestor, considered the ancestor of all life on Earth, is estimated to have had hundreds of genes. That's what we're talking about. Encoding for essential functions like DNA, replication, protein synthesis, and RNA transcriptions. And by the way, all of those require enzymes, but let's say it doesn't. In essence, the origin of life, as represented by Luca, required a foundational set of hundreds of genes. So we're still in the hundreds of genes to establish the basic machinery for cellular processes and the ability to replicate and evolve. And there's the site. So response, hundreds of genes. Well, hundreds of genes could be anywhere from 200 to 900. So with 300 being on the low side, I would say that his original example of under 400 genes actually fits. And so does the math, by the way. So now, here's a modern day, up-to-date OOL example. Let's see, this is an article. Let's throw mathematical light on the origin of life. Okay, and this is December 15th, 2024 from Evolution News and Science Today. Question, what is the minimum number of types of proteins needed for Luca? Quote, by determining the minimal set of proteins required for a basic functioning cell, we can perform probability calculations to estimate the likelihood of a minimal proteome. The complete set of proteins expressed by an organism arising spontaneously, by chance, as a near minimal synthetic organism. So J. Craig Ventnor says that the proteome needs 438 proteins in December 15th of 2024. He's identified 438 protein types, and I will prove that in a minute, okay? as the base. And then the average protein length in his example is 250 amino acids long. Interesting. So the calculations are based, the ones that you're going to see in a moment, they're only based on just 413 protein molecules, but that's not correct, and I'll show you why in a moment. And the information doesn't come from me, it comes from this article. Watch. So here we go with the probability calculation. Here, the first one is for one protein only. Get that in your head. This is the calculation that he does for one protein only. And the probability, the answer is 4.2 times 10 to what? The 251st power. Can you say, wow? Again, Sir Fred Hoyle, anything greater than one chance in 10 to the 50th power would constitute a miracle. So this estimate, the article says, is consistent with other estimates of the rarity of the proteins when scaled by length, and that's true. Notice, again, some amino acids are up to 2,000 amino acids long, and that number would be off the charts bigger than 10 to the 251st power. Now, let's do the total calculation for all protein types. In fact, it's not all protein types. It is. That's what he should have said. And again, we'll get to it. I will show you what I'm talking about. But his calculation is only based on 438 protein molecules. That's it. And for 438 protein molecules to come together by chance, the chance is 4.2 times 10 raised to the power of 109,938. So here is a real world example of what that would be like. And so he did this guy did this in this article. We're going to compare the result to winning the lottery. Quote, let's compare this probability with the probability of winning the Powerball lottery multiple times in a row. And here's the bottom line from the article. Solving for X. We get the result, and it's about 12,996, and this is the bottom line. This means the probability of all 438 proteins, only 438 protein molecules, forming spontaneously is roughly equivalent to winning the Powerball jackpot 12,996 times in a row. But last but not least, and I want you to get this, please understand this, this estimate does not include the fact that multiple copies of proteins would likely be required. And in today's modern understanding of the cell, of course, there are anywhere from 10 to 500,000 copies used depending on which structure or structures in the cell the protein is a part of. My use of the 206 different type of protein types for the LUCA is something that I learned a long time ago. Well, it's now updated, and I would expect that. And that's the thing about this kind of science. It's getting worse for the atheists, not better. Well, the number just more than doubled. It's more than 206. It's 438 now. That's interesting, isn't it? And you know what? I really do. I want to thank the atheist who debated me. I really do. It got me to go in and get some more information and update my information and be able to present it to you guys. So I want to thank the atheist who I debated, and I hope he gets to see this video. I'm going to put a link out there where we debated and see if he'll watch it even. I doubt he will, but anyway, I just want to thank him for it, and thank you guys for watching, and I hope you enjoyed it. Appreciate it. Have a great day. Bye.